Hello there, math fans. This is a video for my pre-calculus students on an extremely common error, something I've been seeing for 20 years of teaching, and I've phrased it over many years. I started phrasing it in how much older I am than you, and unfortunately that question's been getting worse and worse. But it just came up today, so thank you again for a student that asked this. But there's a problem in the homework that basically says this is the population of one town, and these aren't the exact numbers. I'm calling this town Moo Moo. And this is the population of the town Baba. And the problem says, I don't know why I made those up, but when does Baba have 25 more people than Moo Moo? And students just sort of don't know what to add. They say, well, Baba is bigger, I'm going to add 25. They get the wrong answer. It's an extremely common mistake. I feel like if you went on the street, more than half the people would set this up wrong. And so I want to say something about it, and I'm going to tell my story first. So here I am. I'm about 25 years older than my students. What does that mean? Whose age do you add the 25 to? Again, most people set this up wrong. So let's say this is my age, A for Andy. And let's say this is your age, Y for you. And you're one of my students. And we write, so before I write the age down, I would like to write down two questions. And this is what you can always do, and then I will explain how to think through it. So 2 comments before I write the number down. Which one of these equations is right? I should probably do this as like a survey on the first day of a class. Which one of those equations is right? So think about it for a second. Again, A is for me, Andy. I'm 25 years older than my students. A is my age. Y is your age, or my student's age. Which one of those equations is right? It's amazing how hard that is, that people's intuition are wrong. Like I said, more than half the time people write this. They add 25 to the bigger number, which doesn't make any sense. But well, I want the 1 in 25. I want the 25 on that side. That's not what we want. So here's my 2-step solution to this problem. Ask 2 questions. Which is bigger? And over the years of doing this, I've never had anyone do that question wrong. So read the question again, and which is bigger? My age or my student's age? My age. That's just a little fail-safe. At the end of the problem, if you realize that you didn't come out to getting that number bigger, something went wrong. The next step is to go to the smaller one and pick numbers. This is just an experiment. So I have found that if I tell students to do these 2 things, they tend to get it right. And I typically tell them to pick a number for the smaller one. So let's say your age is 20. I feel like the moment I write that down, people know what to do. Do you add 25 to that or subtract 25? So, like I said, the moment you write it down, you know what the answer is. If this is 20 and this is 20, which one of these equations is right to get my age? And I'm not -5. You have to add to this to get this. The smaller number plus the thing you're adding equals the bigger number. The thing you're adding should be on the smaller side of the equation because it's smaller number plus what you're adding. Okay. Now to this question. Let's play our game. When does Baba have 25 more people than Moo Moo? Which is bigger? When does Baba have 25 more people than Moo Moo? Baba will be bigger. This will be bigger. So now we have a fail-safe. At the end of the problem, that number should be bigger. So I should take the smaller. So this is kind of like my A and my B, my Y. Or let's label them A and B. So in this case, the B is bigger. So B is going to be the smaller thing plus 25. So what does that mean? Whatever comes out of this formula, the smaller thing, I need to add 25 to that to get the bigger thing. Okay, So that's how it should work. So put the bigger one, the baba, here. And it's nice that I have that fail-safe in the back of my mind of, oh, at the end of this problem, I can double check. So I feel like if you don't have that kind of two-step thinking approach, this is the smaller thing, whatever comes out of that. This is the bigger. And now we can solve. I subtract the 6x, I get 2x. I can add the 5, which makes it 3 plus 2x. I don't know why I did it like that. So I get 2x. Let's go here. 2x is 28. I get x is 14. Now I can run my failsafe. What do I mean? I can plug in a 14 here. I didn't prepare this. And I can plug in a 14 here. I should know this, but since I'm doing this, we're going to do 6 times 14 minus 2. So that I'm getting moo is 82. And I'm going to do baba. 8 times 14 minus 5, 107. So now I can check my failsafe. Was the correct thing bigger? Yes. Was it 25 more? Yes. So I don't know if that will help with these sort of problems. It goes for any problem where you're saying this is bigger than this is smaller than that, and you already have two formulas, or this is twice that. Always ask yourself which is bigger, run an experiment, test at the end. I hope that helps deal with those sorts of issues.